Good morning, sir.
Good morning.
Good morning,
Good morning, sir.
Morning, sir.
Good morning. Good morning.
Good morning, sir.
Good morning. We'll start in a while.
Good morning, sir.
Okay. Good morning, guys. We'll start the class today. I think you are going to report it soon for the offline classes. Am I audible?
Yes, sir.
Okay.
Yes, sir.
Yeah. So what were we doing yesterday? Something very complex. That is,
Trigonometry.
yes, we just tried doing something in the second quadrant, the complementary angles in the second quadrant. But very few are in the online class. So Even yesterday, I've seen very few. So you're coming tomorrow, everyone? Like your reporting is 9th or 11th. What did you get the notice?
9th, sir.
9.
9. So yeah, please be as quick as possible. We'll start the offline classes, which are more productive than the online class, obviously.
Excuse me, sir.
Yes.
Sir, is the new boys campus ready?
Yes. For you, for the classes and hostels are ready.
Oh, okay, sir.
Yeah, all the necessities are there. We can do it. No problem. Monday we'll have a class in the boys campus. Don't worry. If you report it tomorrow and day after tomorrow on 11th, we will start the offline class. What?
So there will be classes on Sunday, sir.
Yes. Sunday, no, not Sunday. Monday. Most probably you'll have a class on Monday. If at all you report a decent good number, enough number of people report to the campus, then we'll have a class on Monday.
Sir, is there Eid holiday?
Eid holiday, yes. I think all the GH government holidays are holidays in the campus, but not for the hostless.
Sir, so we have classes tomorrow.
Tomorrow, no, I don't think so, because you are going to report. Even today, many of you are not online. So we'll see. With this number, I can't teach any new topic. We'll just revise what we have learned till now. Okay. Because again, we have to teach the same thing again and again. We started for the girls. We just finished the 4th quadrant for the girls in the trigonometry. It will take 2 days for us because it's a double track. So yeah, we can finish it in 2-3 days. It took me like 3 days to cover up all the missed online classes. Very few are attending the classes and very few are attentive. Like out of 100, if you go for the percentage, there are only 30 or 40 people doing good with this online classes. The rest of the 60, 70 are not good enough with these subjects. So yeah, even we don't prefer this, because we don't know what's going in your mind, how you're reacting
Your
in the
voice
class.
is breaking.
So yeah. Okay. Yeah. So many of your friends, the girls, have given me some doubts. So if you have any doubts regarding any track, not about this just on alone track, if you have any doubts in any track, you can just discuss about that, because with this number, I don't want to do anything new, especially the 2nd quadrant, 3rd quadrant ones.
Sir, can you explain functions, sir?
Functions, functions as a whole. Yeah, it's okay. You will do with functions in November, not soon. Okay, the track, according to the schedule, you will be doing the functions in November or October, something like that, after your Dasra.
Due to some network issues, I couldn't attend those classes, sir. That's why I was asking you since you...
Okay, it's okay. Fine. Good. No problem. Which part of the functions topic you want? Like, we have discussed it in a very good way. We have done some graphs as well. So,
From the beginning, I wasn't there, sir, actually.
okay. I can hear some girls' voice. Any girls in the online class? Okay. It's okay. Yeah. Yeah, mute your mics, everyone.
Sir, it is Shashank.
Yeah, Hanish and Shashank. Yeah, okay, fine. Shashank.
With over 5 million authentic ratings and reviews on North Sure about it.
Shashank. Yes. Okay. So this is what happens in the online class. They do something else. Okay, this is why I don't want to do this in online class. The experience is that online classes are not so productive for all. Those who are doing, they'll do it wherever you go. Like if it's online or offline, no matter what, they'll do this. But few are there who are on the middle path. They need some disciplinary activities sometimes. Okay. It's okay, fine. So Yeah, you're asking about the functions, right? So
Yes, sir.
firstly, can anyone say what is a function, by the way?
Function is a special type of relation.
Yeah, it's a special type of relation. What is it? It's a relation. It's a special type of relation. Yes. Yeah. What is function then?
It's a subset of relation.
Subset of relation. Okay. Yeah, we can call it like that as well. But what is function, by the way? If you do with these
If you
definitions,
give
yeah,
input, they'll give output.
yes, that is the raw way of getting into functions, and that helps you in solving problems in future. So function is a mission where you give input and it gives you outputs. Okay. Function is a performance of a machine or a computer or a robot or something like that. You give some inputs. So suppose you give some input to walk for 10 meters, it will walk and it will show you. Okay. So that is how it works. So you give some inputs. Inputs are here. These are the inputs, so-called sometimes it is called domain. This is outputs range, or sometimes also called codomain. So this is domain. Okay, inputs are in domain and these are in range. Fine. So can anyone help me? What is not a function then? When do we say that this is not a function?
When there is no input.
When there is no input, that's it.
Then there is no output.
When there is no output, no, not like that.
One input with two or more outputs.
Yes. Yes. So we don't deal with without inputs and without outputs as a function, because we try some inputs, then we'll find some outputs as well. Then we decide what kind of function it is. But if you get two outputs for a same input, then you say that this cannot be a defined function. So that will not be a function, because suppose if I give some input, so if I give input to walk for 10 meters like that, what if it walks and runs at a time? So like, or something like, if I ask you at t is equals to 10 seconds, where are you? Or at this time, where are you? If my outputs, the answers are like, you are in the college and you are at the home listening to the online, both at a time, which one to decide whether you're in the college or at your home listening to the online classes? So there is some gamble in the outputs, right? So we cannot decide what kind of performance it is. So if I get two outputs at a time for a single input, I cannot define that function that if I give this input, it will give this output, because it is giving multiple outputs. We cannot come to a conclusion that this function does this thing. Suppose if there is a function, if there is a mission where you give some input and it gives you multiple outputs, can you give some other input to get a particular output next time? So I mean, see, when you are checking for a function, first you have to learn about the mission. Okay, you have to learn about the mission, then you start using. Suppose you know that if you press the acceleration, you know that your vehicle accelerate. Suppose if you accelerate it once, it will accelerate and decelerate at a time, both. Sometimes it gives jerks, like it will accelerate, it will decelerate without intimating you. Then the next time, will you be ready to push the acceleration button to go for the more speed? No, sir. We cannot judge it, right? We cannot come to a conclusion that the acceleration function does acceleration alone. Or suppose if you accelerate it for 10 meter per second, so it should increase it should increase with 10 meter per second. It should the velocity should be changing with 10 meter per second for second. What if it changes to 25 meter per second suddenly? Then you will be worried about what happens next. If you press the acceleration button, you don't know where the car takes you. So when you cannot sense the function, it is not a defined function. So a function should be defined in a proper way. Okay, such that you have to guess the next output for a next input, some other input, such that you give inputs in a way that you get required output properly, I mean, this is too much of um, too much of knowledge. It's okay. So for a one input, you should have only one output. I mean, for multiple inputs, you can have multiple same output. Suppose you can have like this. Suppose you can have like this, because this is fine. Suppose if you are at rest at t is equals to 1 hour, you will say you are here. At t is equals to 2 hour, you will say again you are here. At t is equals to 3 hour, you will say again you are here. That's fine. We can define that he is not moving. Even if you give the other thing, you will be here only. I can sense it because you are at rest. The function is at rest. This is a constant function. It is a not changing function. It's a constant function. So it is also a defined function. However, there is only one thing to check. So this is the only statement you have to check. If you have multiple outputs for a single input, that is not a function. Just check for the function. There is only one condition to check for the function. That is, for a single input, you shouldn't get the multiple output. That cannot be defined as a function.
Okay, sir.
Okay.
Sir, but multiple inputs and one output, that can be defined as a function, right?
Yes, that can be defined as a function. Yes, you see, you can say that if you give one more input, you will say, yes, that is not moving. So if it is not moving, then yeah, it will be same. You can get the output, right? Even if you check for another time or another value, it is not moving. So it is defined. If it is moving in two directions at a time, can it happen? Generally, it cannot happen. If it happens for your input, so you cannot say that where it is going or where it is stopping or something like that. You cannot define its profile. So generally with the inputs, you should be able to define the profile of the function. You should be able to say that this is going to happen next with some other input. That is the only way to check whether the function exists or not. Okay. If you have multiple outputs for a single input. Now coming to the among that, if first thing, it should be a function now. So to check the function or not, you have to check for single input, whether you have multiple
Sir, your
outputs or not.
voice is not clear, sir.
My voice is not clear or not audible.
Audible is clear, sir.
Yeah,
It's clear.
I can hear in my PC as well in my laptop. Yeah. Yeah. So now if it is a function, it can be 1 or onto. What is 1 function?
Individual output for one
For
input.
every input, there is only one out.
Yeah, for distinct mean different inputs. For distinct inputs, you should get distinct outputs. That is, it should be like a one-on-one fight. For one input, you should get only one output. Before, someone asked me, for multiple inputs, we have one output. This is a function though, but this is not a one-one function. See, many are mapped to one, right? Okay, so if many inputs are mapped to one function, one output, that is not one function. Every single input should map some other output which is not mapped by any other input. It should be properly distinct. Okay.
Yes, sir.
Yes, sir.
Yeah. Suppose if I give A, B, C, D and 1, 2, 3, 4, 5. If I map A to 1, B to 3, C to 4, is it a 1 function now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So if there are any left out inputs or outputs,
Sir,
Do they matter for a function to be defined as 1, 1 or onto something like that?
No, they don't.
Yes. So for 1, 1 function, even if few inputs and few outputs are left out, it's okay. Okay. We have to only check whether the one element is with only one or not. That's it. Don't bother about the left out elements for 1, 1 function. That was the question raised by your friends. Okay. That's it. That is a small thing called 1, 1. Onto was a 1, 1. Now we'll go to onto function.
Sir, in the definition, if x1 is equals to x2, then
Yeah.
f of x1.
Yes.
Can you
Yes.
explain it, sir?
That is really tough to convince you. Okay. See, I'll say that my f of x1 will be f of x2. What is f of x1 and f of x2? They are some outputs. Okay.
Yeah, sir.
So outputs for some inputs. So this I gave some x1 input and x2 input. For two inputs, I got the same output. Right? That means the same. That defines that, right?
Yes, sir.
Yes. So if my f of x1 is equals to f of x2, then it will happen if and only if my x1 is equals to x2. This output, this is a single output for two different inputs, right? According to this thing. But my
f of x1 and f of x2 are outputs.
Yes, these are the outputs, but the same output, because we got it as same thing for two different inputs, x1, x2, we are getting the same output. I'll say that this will happen in 1, 1 if and only if my x1 and x2 are same. That is, my inputs are same. It can happen only if my inputs are also same, like my outputs. That means this will happen only for a single input. That is x1 should be equal to x2. If my x1 is not equal to x2, my f of x1 cannot be equal to f of x2. If I get two inputs which are not equal, my outputs also not equal in 1, 1 function. If my outputs are equal, that means they must have come from the same input. There shouldn't be two distinct inputs for a 1, 1 function. Okay.
Yes, sir.
This is a game of English here. Okay. It's okay. No one will ask you about this. This is just a theorem which we use for some IP, something like that. You'll get to know about that after that. Don't worry. These are the corollary or something like that. The statements are called something like that. Don't worry. If my outputs are equal for different inputs, we define that. Suppose if x1, x2 are like this. If these outputs are equal, that means these inputs shouldn't be different. They should be also same. They should be just A, not AB. Both the inputs also should be A. If my output is same, my inputs also should be for that. So that means the output which has come for something must be only from a single input, not two inputs, two distinct inputs. Okay, clear?
Sir.
Oh, thank God.
Sir,
Okay.
can you explain Pascal's triangle?
Pascal's triangle.
Yes.
Oh, wait. Yeah, after onto I'll teach the Pascal's triangle and we'll end it. Okay. Yeah. What is onto function now? Can anyone tell me what is onto function?
For every pre-image, there should be an image.
For every image, there should be a pre-image, right?
Yes, sir. Yes, sir.
Yeah, fine. So this is image. That is, for every output, there should be at least one input defined. Okay, suppose if I give A, B, C, D here, and 1, 2, 3, 4 here. Okay. If I give it like this, if I map A to 1, B to 3, C to 4, and D to 2, that is fine, because all the outputs are mapped for some value in the input. Or if I give like this, A, B, C, and 1, 2, 3, 4, 5. Okay, if I give like this, if I map from A to 1 or B to 3 or C to 4 like this, is it an onto function now?
No, sir.
Yeah,
No.
just check for the output. Yes, that's right. Just check for the output. If you get any element which is not mapped to the input, then it is not an onto function. No element in the output should be left without mapping. Okay, everything in the output should be mapped. Fine. If I do it like this now, is it an onto function?
Yes, sir.
No, sir.
Not a
No.
function. Sir.
No, sir.
Yes, it is not at all a function, right? First thing, it is gone there itself. No parent. How come the child come? Okay, so that is like, this is not at all a function. Don't think about the onto function. Okay, good.
Sir, one input cannot have two outputs, sir.
Yes, that is why this is not at all a function. Then why do we deal with one and onto again?
Okay, sir.
Yeah. Yes. So if I give like this, A, B, C, D, E, F, and 1, 2, 3, 4. If I map like this, I left E, F in the inputs. Is it an onto function?
Yes, sir.
Sir.
Yes. Yes.
Yes, sir.
Okay. So yes, even if you leave some elements in the input, don't deal with that. Just go for the output, whether the output has got some pre-image or not. If we have, for every output, we have a pre-image. So this is onto function. Cool. So what does that mean? We can sense one thing. See here, we have 5 outputs, only 3 inputs. So it cannot be onto at any cost, because out of 5, we can only map for 3 at max. We cannot map for double things. So number of outputs should be less than or equal to number of inputs to become an onto function, right? Outputs should be less than or equal to inputs. They can be equal sometimes, but they cannot be more than inputs. If they are more than inputs, then it is not an onto function. Okay.
Yes, sir.
Yes.
Okay. Yes. So yes, someone is asking about the Pascal's triangle. So how did you know about this Pascal's triangle, by the way?
Ram sir said.
Then you must have learned it properly there itself. Then why again? You missed it or what? So yeah. Okay. If I write A, so how many of you know this identity is A plus B into A plus B again? This identity A plus B into A plus B.
The A square plus 2AB plus B square.
Yeah, don't write like that first. Okay. First write it as A into A plus B into A. No, A into, sorry. Next A into B plus B into A plus B into B. Right? So because we deal with real numbers, now A into A is A square. We can write like this. AB and BA are same. So that is why it is 2AB plus B square. Because we are dealing with real numbers. Yeah, please mute your mic. Okay. Yeah. Thank you. So what are we doing is, we are getting a AB, BA from 2 things. So the AA has come again, the BB has come again. In between, the 2AB has come again, like this. Like it has got added from BA and AB. So the Pascal has got one idea, and to make it simple, so because this is A and B, he made it like this. So in a 2-degree equations, because A plus B into A plus B is a 2-degree thing, so he made up like this as AB and 2. And he carried the 1 here and here. That is, it has become like this, the 1 and 1, and this became 1 2, 1. When you add 1 and 1, it is 2. Okay. And again, put 1 here. When you add 1 and 2, this is 3. When you add 2 and 1, that is 3. And 1, again 1. Okay. When you put again 1 here, when you add 1 and 3, it is 4. 3 and 3 is 6. 3 and 1 is 4 again. 1 again 1. So the triangle goes like this. Can you tell me the fifth one?
1, 5.
1, 10,
1,
5,
5,
10,
10, 5.
10, 5. 5,
1,
5,
5, 10, 5, 1. Okay. So then how to write it? This is a plus b. Okay, fine. This is a square plus 2ab plus b square. That is also fine. Then how to write this? This is a plus b whole cube.
A cube.
yes, sir.
A cube plus
B cube.
no.
3a square
Using Pascal.
3ab
That will
square.
be 3a square b
3ab square
3ab square
B square
plus
Plus
b
plus
b
cube.
b
cube.
cube.
See, to avoid confusion, I'll tell you one thing to keep in mind. This is a cube, right? We have a square, a, and a power 0. That is a power 3, a power 2, a power 1, a power 0. The a keeps going down. And similarly, b power 0, b power 1, b square, and b cube. B keeps increasing. A keeps going decreasing. B keeps increasing. Okay. Similarly, here it is a power 4 plus 4, a cube b plus 6, a square b square. So a is going down plus 4 a b cube plus b power 4. Okay. Now write it for the a plus b whole power 5. Yeah, those who didn't write in that class, write for a plus b whole power 5. So similarly, it will be the same for a minus b as well. So there shouldn't be any confusion how to deal with a minus b. So just write a plus of minus b. A minus b as a plus of minus b. Where you see odd number of b's, you put the minus there, right? So here I have only one b, I'll put minus here. Here I have one b, I'll put minus here. I have two b's, it's a plus. Three b's, it's a minus. So one b is minus, two b's are plus, three b's are minus. Got it? How to put a minus b whole cube now?
Yes, sir.
Yeah, wherever you see odd number powers of b, it should be minus. Okay.
So I didn't understand the passage. Can you explain again?
There's nothing to. So this is the 2 comes from addition of 1 and 1. The 3 comes from addition of 1 and 2 and 1 here. The 4 comes from 1 and 3. 6 comes from 3 and 3. 4 comes from 3 and 1. So the triangle
Okay,
grows.
sir, I got it.
Yeah. And this can be applied somewhere else. How many of you are aware of tossing a coin probability in the 10th standards?
Yes, sir. 1 by 2, sir.
Yes.
Yes,
Yes, by 2, sir.
Yes. I'll connect this to that now. See, suppose if I throw a coin, if I toss a coin, what is the probability? I can get a head, I can get a tail.
1 by 2.
Yes. If I throw the toys, if I toss the coin two times, what is the probability? I can get a head
2 by 4.
and
Head, tails, head, and head,
no.
and tail.
Wait. Let us go in order. First can be head and head. First can be head and second can be tail. First and tail and head,
Yes.
tail and tail. Is this the thing?
Yes, sir.
Yes, sir.
If I throw it for 3 times, head,
Head,
head, head, head, head,
head,
and tail. Okay. Now head, tail, and
tail.
head, head, and tail. No, head, tail, and tail. Then tail, head, and head, tail, head, and tail. Tail, tail, and head, tail,
9
tail,
times.
tail. It is 8 times. It goes for 8 times, right? 1, 2. So it is 2 square times when you put 2 twice. If it will go for 3 cube, 2 cube times if I throw it thrice, it will go for 2 power 4 times when I throw it for 4 times, right?
Yes, sir.
Yes. See, you will see one thing here. Now I'll write it in this way. So this is for first once, for now it's twice. If I throw for twice, this can be head, head. This can be head and tail, right? The head can be divided like this. The tail can be tail head and tail tail, right?
Yes, sir.
If I throw it twice. So this will be my h square. This will be my 2ht. This will be my 2t square.
Yes.
Suppose if I ask you, what is the probability of getting 2 heads if I throw it twice? What is the probability of getting 2 heads at a time? When I throw it twice, see here, I throw it twice. Yes, 1 out of 4.
1 by 4.
2 by 8.
Yes. Yeah, it is 1 out of 4 because I have 4 options and the head and head option is only once out of 4. If I ask you, I should get a head and tail.
1 by 2.
1 by 4.
1 by 1 by
Yeah, I
4.
have two options here to get head and tail.
Sir, 2 by 4, 1 by 2.
Yeah, so it is 2 by 4. If I want 2 tails, again it is similar to 2 heads, that is 1 by 4.
1 by 4.
Right? Okay. Now if I ask you, I want, if I throw thrice now. Okay, I throw thrice and I want all the heads.
1 by 8.
1 by
1
1
by
by
8.
8. Only once. Yeah, only once for all the heads. Yeah. I want 2 heads and a tail.
2 by 8.
3 by 8.
2 heads and a tail, 2 heads and a tail, and a tail and a 2 heads. I have 3 times. So it is 3 by 8. Then 2 tails and a head.
3 by 8.
Yeah, 2 tails and a head is also once, and once. Yes, 3 by 8. All tails, 1 by 8.
1 by 8.
So see, 1, 3, 3, 1. 1, 2, 1. So see, it will be like this. 1, 2, and 1. Similarly, it will be 1 for h cube, all the heads. 3 for h square t. 3 for ht square. 1 for t cube. If you add all these things, 1 plus 3, 4 plus 4, total 8.
8.
You got 8 possibilities here.
Yes, sir.
You got all the 4 possibilities here. 1,
Yes,
2, 1.
Yes, sir.
You got all the 2 possibilities here, 1 and 1.
Yes, sir. Yes, sir.
So similarly, if I go for 1, if I go for 4 times, 4 h cube, it will be 4 h cube, 1 h cube, 4 h cube t. Is it 6, right? 6 h square t square, 4 h t cube, and 1 t power 4. If I add all these things, 1, 4, 6, 4, 1, is it 16 now?
Yes, sir.
Yes, sir.
If I ask you, I throw a, I toss a coin for 4 times and I want 2 heads and 2 tails. What is the probability? Can you tell me now? 2 heads and 2 tails when I throw it for 4 times.
6.
Yes, it is 6 by 16, right?
Yes.
Yes, because See, if it is 2 tails or if it is 2 times, you can count on your paper. What if it is for 10 times? We cannot do it, right? So there we can expand this h plus t whole power 10. And you can find the coefficient of that required number of coins, required number of heads and tails. Here I asked 2 heads and 2 tails, and you got the 6 here in this expansion. You can say 6 by 16. If I ask you 1 head and 3 tails, what is the probability of getting 1 head and 3 tails when I throw it for 4 times?
4 upon 16.
Yes, 4 upon 16. We can connect this to that concept as well in the probability. Pascal has got a lot of applications. We tried proving that this 1 and 1 makes 2 and 1 2 makes 3, 2 1 makes 3 again. This one always carries like this. Okay, these are all the chances, the chances we count. The a plus b is equal to h plus t again. We discussed this the same thing in binomial theorem as well. This is a second year topic, completely second year. Yeah. Yes. Do you have any doubts regarding this ht th? This is something I don't think you'll learn it in a 10th class. You learn the probability, but you don't learn this in this way when it comes to the coins. Suppose in the same question, we'll say this h and t has got equal chances because the coin is unbiased. If I bias that coin, suppose if I quote some extra like this, if I do some plating on other side to make it more weight, so the more weight thing will go down. When I toss the coin, the probability will go up for that. So the probability of the lightweight coming up will be the more. That means, suppose if the probability of getting a head is made into 0.3 and getting of tail is made into 0.7, not half like before. If it is unbiased coin, it is half. Suppose if it is not half, if it is 0.3 and 0.7 like this, then how to deal with that? We can apply same. We can just substitute that h 0.3 and 0.7 and we can put it here directly. You'll get the same value. That is why I didn't put any value. I just put that h as h. You don't get the 16 here. You'll get the 6. Because this 16 has come from this 1 by 2 whole square and 1 by 2 whole square, that is 1 by 4 into 1 by 4. You have 1 by 2 whole cube and 1 by 2, that is 1 by 8 into 1 by 2. So that is why you got 16. For now, we won't get 16. We get some other value. Okay. You can just directly substitute the biased coin as well. This is applicable for biased coin as well. Okay. Do you have any doubts with this Pascal triangle now? There are a lot of applications of this Pascal triangle. Yeah. This Pascal triangle. Yeah.
No, sir.
Okay, guys.
No.
If you have any other doubts, we'll discuss, or else we'll take a leave. We'll see you directly on the day. Okay.
Okay, sir. Thank you.
Yeah. Yeah.
Sir, thank you.
See you soon. See you soon. Bye bye. Yeah.
See you soon. See you soon. Bye bye.
Sir,
Thank you, sir.
sir,
Yes.
sir, can you tell us the syllabus for tomorrow's exam?
Tomorrow's exam. I don't think you'll write an exam tomorrow because you'll be on transit. Many of you will be on transit, moving from home to here. So yeah, just talk to the admins if they ask. They didn't ask me anything to set a question paper or something like that.
Yeah. Okay, sir.
If there is any exam, we'll go with the functions or something like that, small ones, and
Yes,
some
sir.
graphs, small graphs.
And
Yeah.
some graphs.
Yes,
Small
sir.
graphs. Yeah.
Okay. Yeah. Bye bye.
Yeah.
Okay, sir.
Bye bye.
Thank you, sir.
Thank you, Sabai sir.